Welcome to my talk, Software Engineering Completeness Pyramid, knowing when you are done and why that matters, okay? So this is the Bloomberg slide. I have to put it up there. So who am I? What am I doing up here on stage in front of this very illustrious group, right? Well, I started using C++ a very, very long time ago. It's sort of, I think, not long after it escaped Bell Labs and the universities. So I've been using it a long time, and in my professional career, I've been doing a lot of system analysis and architecture. I did spend 21 years as a consultant moving around through a lot of companies. That meant I've seen a broad reach of what's done in code and what's bad and what's good. And for the last decade, I've been in Bloomberg, and these days I apply my trade in what's called the Bloomberg ticker plant. So where you see all those tickers come across the screen, we're the area that takes all that exchange information from all around the world, masses and masses of information, and send out these ticks. Okay. So here we are at the conference. What am I doing here? Well, I like to give engineering talks what I call practical based. In other words, they're based in the real world, which is where most of my coding happens. And I like you to either take something away or have a change of perspective. Your thinking changes because of something like this. All right. So the genesis of this talk is I was going to the Bloomberg offices in London, and one of the managers there said, I want you to give a talk to my guys. And I said, well, what do you want to talk about? Here's the list of talks I've done at conferences. I don't care about any of those. I want you to talk because I am frustrated that developers believe that it's just about the code and they don't keep any handle on the real cost of software ownership. And at that time, I was running a very large project called Linux migration. I was moving our whole architecture and cluster over to Linux. And I was finding a lot of problems similar to that, where I was asking people, are we done with this yet? And I was getting yes, and it was not anywhere near done, right? And we'll go into that a little later. So here's the question that you get asked a lot, especially if you're earlier in your career. Are we done yet? Your manager asks it. What he's really asking is, are you done yet? Right? Is the work we have you got it done? And I would say the answer is probably not, right? From my experience, we have a really poor definition of what done is. So why is that? What's the problem? So the first thing I do is I go to the dictionary and say, well, what does the English language mean by done? And it says to bring something to a required state or completion. Fairly good, but what does it mean in engineering terms? And I look around and for literature and stuff, and there's very little about what done means for engineering. I do find it wrote down in the Scrum Guide. And it says something like the formal description of the state of the increment that meets the quality measures, your quality standards. I mean, if I ask some developer, what's the definition of done? This is not what I hear, right? This is almost gobbledygook to them, right? Even though it is a formal definition. So why bother? I mean, why would we need to say, or doesn't everybody know what done means? All right, when someone says, when is this going to be done? It's going to be done 3 weeks from now. I can walk away, I'm full of confidence it's going to get done. No, I'm not, because the problem is we need to establish a definition of done, right, that creates some shared understanding within my group. Let's say on the local level, within my group or the nearest teams I work with, we have a shared understanding and unified language for what we mean by done. And because of that, new people coming into the group or people that are interacting with the group don't have to try and access some tribal knowledge that's buried out there sort of in the subconscious of all the people. It's right there to be looked at, and we have the proper expectations set. On a larger scale, so if you go up the chain, on the larger scale, across a company or an organization, having a shared definition of done that's agreed to, right, gives a shared responsibility, right, and helps us do what we call alignment of the company, right? If I'm told, hey, we're releasing this thing on when? I say, well, December 10th, we're releasing this big new feature on the terminal. And the publicity group goes into overdrive, and it's, December 20 or December 8th, and they're like, okay, 2 days, we all ready? I'm like, well, no, when I said done, I meant I just merged it in my code base. It hasn't actually had any production testing. It hasn't gone through beta testing. We have this friction in the organization. So that's why we need done at the higher level as well. So I'm going to give you an example. all right? So the goal of your project is to develop 10 new product features and deploy them to the users. But you haven't deployed any of them yet, right? I was going to say, what is your completion percentage, right? Most developers say, well, we got 5 of them coded up, and in our code base, we're 50% done. You're not. You're 0% done, right? We know how to do math. You got 0 features or 0 amount of that work is visible in production. So you've nothing done. Now, at this time, this is where, like I say, managers, developers say, look, we coded and tested 5 of them, so we're 50% there. It's like, you're not, because my definition of done means the customer sees these things, right? That it's out there giving us value. And the better question would be, when do we expect something specific, right? Some new trading done, some new ticker type being delivered to be deployed and active everywhere in production, instead of just saying done, because done is something that people can funge in their head. So that we have a shared understanding between us, I'm going to go through some basic terminology I'm going to be using in this talk, right? What is the business value of software engineering, right? Not the technical, not all our wizardy, templates and reflections. What is the business value that we deliver as software engineers? You can shout it out, right? It's an actual question, it's not rhetorical. Usable features, kind of, yeah. I can't hear that. Competitive advantages, John? Customer satisfaction, yeah. I mean, what we're really looking to do is get people to pay money, to give us money, right? To do our pretty nice salaries, right? So, but what we're trying to do is deliver desired outcomes in incremental steps. Right? Now, why incremental steps? What's with this baby step stuff? Putting in things a bit at a time. Why don't we just big bang changes in? Right? I'm redoing the whole of the communication layer, and it's all coming in 12 months' time. Get ready for it. Right? Because we found that that's, well, I don't know if you guys have found, I was here in the early days when a lot of that was done. We found it's really bad, right? It tends to take your system down. You blow up a lot of stuff. There's you can have long recoveries from trying to put your data back together, all this kind of thing. So we do it so we have shorter time horizons. And because we have shorter time horizons, we have less uncertainty. If I said this is being delivered next month, and here's what I mean, there's more confidence that I'm delivering something a year from now. All right. It's also lower risk inherently, right? I'm doing less change, there's less risk. And we get better feedback from customers. So I'm doing incremental steps and they say, hold on, we're actually looking to have this way. You can start adjusting in mid-step, right? And because we're starting to deliver something in a lot of little chunks, you need to know the delivery of these steps, right? Now, even though we're delivering it in incremental steps, likely for the business, there's a deliverable when a whole bunch of steps goes in. So they only see it when a lot of steps go in. But when you have all these incremental steps, you can plot the time a lot more accurately. So the business value of software engineering, when is it materialized? Right? We have this idea of materializing variables in C++. When is the value actualized? You do a nifty new feature, when is that actually materializes value? Not when you get paid. You'll probably get paid, that might drive your company to the ground. You'll probably get paid anyhow. When the company gets paid, yes, but it's going to get paid for something. Right? Look, so it gets actualized when it's available, when your customers have access to it, right? When you fix a bug they no longer have to deal with or have to do workarounds. So when it's available. When it's usable, in other words, it actually does what it says it's going to do. If it's a service, it's up when it needs to be up, all right? And reliable. In other words, it doesn't work 5% of the time, 10% of the time. It's got to work all the time. If it's a service, it's got to be up all the time, or there is defined periods of downtime that your customers know about. So that is when it's materialized. That is, I'm going to say, a very immediate view of the value. This is what your customer sees, which is very important. But there is more value that we put into the software, and that's to do with future looking, right? So if our code is configurable, in other words, I can add new configuration and have it do new or more stuff, that's value. If it's flexible, in other words, I can make it do new stuff and it doesn't take total rewrite of the code base, that's good. We can fix issues quickly. We can locate and fix them quickly and have them tested. That's also good. And we can evolve quickly with the market. So as the market's changing, our software is not so serpentine that getting any little change in, we break stuff all over the place and we don't quite know why. So, and this is the interactive portion, all right, this is where you get all your street cred. What types of improvement do we as engineers deliver to production?
Speed.
You've seen my talk, you can't talk about stuff.
Speed.
No. All right, yeah, new features. I mean, I'm in a room of engineers. It always makes me a little nervous when I ask this kind of question in a room full of engineers, just stay quiet. What else do we deliver to production? Huh? Yeah, bug fixes. All right, cool. What else? We actually deliver feature flag changes, but we'll get to performance a little later. We deliver configuration, new configuration. We're going to take in new clients and we have new configuration for them. We're going to have new servers up and running, right? We also should be having tech debt reduction, right? Refactoring depreciation of code that's not being used anymore. That's something else we should be delivering to production. And then we have the actual hardware or the ecosystem that the stuff lives in, right? Like I say, I gave approximately 2 years of my life to getting new machine architecture, right? Linux architecture. Wasn't easy. And that allowed us to go to the latest GCC compiler at the time. So we're now on, I think, 20, and we're looking to move to 23. Right, so these are the types of improvement we deliver to production. But what other types of change do we deliver to production? Bugs, yes. We deliver broken functionality to production. What else? Missing functionality, right? We didn't make the deadline, right? Or it doesn't work, right? We deliver performance issues. Someone said performance issues, all right? I had this happen in a case where I was looking at a piece of code to make a change and I noticed in the hot loop there is a cout, all right? And what happens is I showed the guy who made the change and he was like, oh, that shouldn't be there. And then we went to look at one of these dashboards and turned out that 3,000% uptick in the timing to do this particular type of transaction, right? So performance issues. Security issues, it's a big thing now, right? We have a few talks talking about security. System unreliability, the aggregate amount of change is coming in, it's just making our system more brittle. We're getting more falling over, more service interruptions, more downtime. So production changes. Right, what do we need to know? What do we have to have for a commitment to deliver a change? What do you need to know? I have a change. I have a change. What do you need to know? All right, you. I'm going to say you have to know what you're delivering first, right? I think this is something, maybe a little controversial, we're bad at. We tend to get the merest hint of what we want, and then we just run off down the road, right? We go woof down the road, right? And then we find out we're going over a cliff, right? So we should have something to keep us, on track. And something we have for that is called acceptance criteria. So what are acceptance criteria, right? These conditions we have to meet that the software change will be accepted by the user or the proxy. It can be a business analyst, someone from the business side. But it's something that we have to meet. And these things should possess certain qualities. I see acceptance criteria that are, we're going to deliver something kind of whenever, right? It's like you can make that acceptance criteria stick because there's no specifics in it. So it should have some clarity. They should be straightforward, easy to understand. They shouldn't have a load of prose or telling a story behind it. It should be very this is what we want, very concisely. And we should have a way of testing it. How do we know we have it done correctly? What is the success to get this done? And also should be observable. Again, something we miss a lot. We say, we've done something absolutely fabulous in the code base. You're not going to believe it, Mr. Business Person. And he goes, well, what is it? What am I getting? I can't tell you because it's way in meta programming. You just wouldn't understand. And he's like, well, I'm just clicking the buttons. Nothing looks different. So you have to give them some sort of observability. And that's something you should be looking for to show the impact of your change. And very important, acceptance criteria are about what the change will do. The business does not tell you how to do it, or really anyone else shouldn't be telling you how to do it unless they're just trying to help you out, right? It's about the what, not the how. That's the engineering department's mandate, is to figure that stuff out. So when you write acceptance criteria, it's written by you or the product owner, usually shared with the team so you can get some group think, right? You get like a better idea. People know some of the history of the software. We can make sure it's all copacetic. Here's the piece we miss, right? We like to be what I call a self-licking lollipop. In other words, yeah, we wrote it and we all think it's great because we wrote it. Let's just plow ahead and do it. No, you got to go to your customer or whoever's the proxy of your customer and say, here's what we're going to do. What do you think? And it should be in language they understand, not, again, here's a piece of code I'm going to write, right? It shouldn't be in coding terms. When I've done it, I've used the given, when, then. I'm not going to go into this a lot, but this is just where you say, here's my scenario. I was doing this migration, and I was having trouble where the reference machine, because doing A/B testing, the reference machine had something wrong with it. It was getting a bunch of noise in my results, and I just said, listen, given I have comparison testing going on, when the reference machine has a bunch of things saying it's out of whack, go get something from a backup list and redo until it works. All right, very specific, and this was a quarterly goal, one of the quarterly goals I had when I was running a few teams for the Linux migration. So to know what we are at, let's talk about requirements and scope. What is project scope? Yes, John. Not bad, not bad, right? John said it's what we're going to deliver and where we draw the line, which I assume is what we're not going to deliver, right? So project scope refers to all the list of features and deliverables we are going to commit to on this project. It can also specify items that are out of scope, right? That this is what we're definitely not touching, even though this sounds like we're doing it, this here says we're not doing it, right? What is the debt of projects? What is the thing that kills projects? Huh? I can't quite make out what you're saying.
Compromises to fix later.
Yeah, true. Not quite what I'm looking for. Anyone else? Scope creep. Yeah. Scope creep is the one thing that is going to kill your project. You haven't properly said, here's what I'm going to do. You've left it all vague. Or you've said, here's what I'm going to do. Someone comes in, while you're doing that, can you put in this new nifty piece of functionality? And you should be like, sure. What's my timeline? My timeline's going to go out X month. Are you okay with this? We can maybe rearrange how stuff is delivered as deliverables, right? But if you don't, you can't just absorb everything. I know as engineers, we're like saying, yeah, well, I'll get that done, no problem, right? Because at the beginning of a project, time seems almost infinite, right? And when you get to the actual middle to the last third, it seems like there's none of it around anymore. Okay. And requirements should say what it's doing in bounded terms. General language. I'm going to do equity trading. It's almost meaningless. There's a whole bunch of trades I know you're not going to do because they're complicated. So I'm going to do these simple type of trades for this list of products, for instance. Again. All right, so now I know exactly what I'm committing. Let's say I've got all this down. I know what I'm committing. Can I just walk away and say 6 months from now, I'll come back and see how you're doing? Or maybe a month from now, because we're doing it in increments. What else do I need to know? Kind of give the game away, right? You need to know the timescales involved, right? It's not just enough knowing what's going to be done. You have to know when it's going to be accomplished. All right, so when will the change, bug fix, whatever, be done? All right, so a few answers I used to get was whenever, when we get around to it, whatever. It's not really a timing issue, it's a priority issue. They just don't think it's worth doing. I'm sure if, the department head came down and said, well, when will this be done? I'd be like, oh, well, I think it'll be done in 2 days, but let me get back to you. I have to look into it, right? So it's just priority problems. I've actually got this said to me soon, like in a wee while. Well, okay, let me plan my project timelines based on that. Everybody's saying soon, a wee while, a little while, a bit more of a while. You can't run a successful project that way, right? Unless you're lucky. A couple of weeks or a month, we're taking down the uncertainty each time. right? But what I asked for is a date. I was running, like I said, this large project. When people say, oh, we'll have this in 2 weeks. I was like, I don't understand what 2 weeks is. What's my date? And, I got accused of using aggressive language by asking for a date, right? Sort of like not giving them a date, just saying, you give me a date and I will hold you to that date. All right, so an actual date is what you should be getting, not these vague terms, right? But most engineers have misplaced optimism. We talked to a bunch of engineers, I don't know, down here in the cafeteria. How is your job? Oh, no idea. The problems, the burden, it's awful. And then when business or management says, hey, when can we get this change in or this thing done? It's the most happy path estimation you can possibly give. It's like everything going absolutely swimmingly. I can get this done like really well. It's like a best case scenario. It's almost like that code is right on my IDE right now. And I will make that fix. And if done just means I save that code in my own private view and it works, I'm done. Right? Where's the customer in all of this? Right? Where's the deployment in all of this? Where is this stuff getting out the door? It's not. So usually a bad definition of done. Another thing that's often forgotten is, and I got tripped up this once or twice, it's like, how long does it take this change? 2 days. All right, so Tuesday, release cycle's on a Thursday, so it's going to get in. So I do all my testing again, and I'm doing my end-to-end testing in production. The bug's still there. And I go to them, why is the bug still here? You fixed it and work. And they're like, well, no, we didn't start on the bug yet. We said it was 2 days. We didn't say we're going to work on it now. That's 2 sprints down the road or something like this, right? Stuff that you think people would mention to you when you're asking when a problem would be fixed, but, it's not done all the time. So, and there's this thing called domains of problems, a simple problem, very straightforward, just fixing a calculation. There's one right solution. Then you have, complicated, which means that there's multiple right solutions. So you have to pick the rightest one. There's usually more moving parts, maybe more groups involved. Then you have complex problems. And complex problems is, I don't know what the right answer, not even sure there is one, I think there is, and I've got to go and find a whole bunch of unknowns and narrow them down to figure out. So that's your domain type. So based on the size and the scale of your problem is how much that certainty is going to be in there. So good time estimates, right? What do these do for you? They create trust, and what people call political capital with your customers, right? Or other teams and managers, right? Where you're like, you're very good at delivering product, you're very good at doing it on time. You ask them for a favor, I need to push things around, they're disposed to help you, right? And they trust that what you're doing is the right thing. How do we give better estimates? What is the one thing, Jason, that we would do for better estimates? Can anyone help him out? He says he hasn't worked in a team, he's an independent contractor. Okay. Anyone else? How do you give better time estimates?
Epic bar times 4.
Nope.
Times 3. Practice.
No, casting, John?
Data measure and be realistic by predicting the next project based on previous project.
Yes, but that's one step after what I'm going to say. No, it's not giving it to ChatGPT or Claude. No, right? It's to break changes down into small pieces, smaller pieces. Phased approach to change. We talked about this, right? If there's one thing you do, you break things down. And I've told the story before where I had someone and I said, listen, how much to get this fixed done? How long? And he said, 3 or 4 weeks. And I said, break that down into the pieces. And he broke it down into the pieces for me. And I said, now, can you put the time scales on these things? Right? And it added up to 5 weeks, right? Because once you bring it into smaller increments, better certainty, better confidence interval, if you like. Yes, Jason.
I have a question about that, because there's the like Scotty, right? Where you take your estimate and then double it.
So he's talking about the Scotty principle, which is the enterprise where you say, that's going to take me twice the time. Whatever you think, just double the estimation. Yeah. If you're a horrible engineer, that is the way to go. I know you're not. Like, so we're going to talk about this a little further on, so I won't dwell on it here, but there is a place for that, but not in that way, right? So there's a better way of doing it, right? The other way we already talked about is having specific requirements, right? So that we know what we're delivering. It's not something fuzzy and we're guessing. Another thing is to embrace empirical reality. You know, I tell the story of when I was on a team and we had sprints and we had points of work. If you're familiar, we say this is the points we're going to deliver each sprint. And it came up to 24 points. I was on the team 3 months, 24 points. And yet every single sprint, we only delivered 14 to 15 points. And I said to them, why are we doing, why don't we just half everything we have right now in the sprint? Because that's the empirical reality. And the kind of, engineers don't like to be kind of caught out like that. They eventually came back and said, it's the work we're aspiring to do, right? It's given us a real lofty goal to shoot for. Well, it sucks for anyone using you as a group, right, to sort of try and figure out what's going on with getting work done. So embrace empirical reality. And this is what you're all talking about, a contingency fund, which I think we should have, a contingency fund. Other endeavors, other engineering, someone comes, if you ever watch these house improvement shows, they'll say, this thing's going to take, 100 grand, and I need a 10 grand contingency fund for stuff I don't know that's going to show up. And I think it's okay as engineers to say, this thing is going to take 10 days, 2 weeks, but I'm going to say 11 because I'm going to put an extra day contingency fund. Not 100% contingency fund, right? If someone came to me, was doing my kitchen, it's going to take 15 grand, Pete, to do your kitchen, and I want you to give me another 15 grand for stuff I might run across, I'd say he's an idiot. I would get someone else to do it, right? That's the scale has to be down to 10, 15%, okay? And the other very important thing that we miss is that, and we don't communicate, is as we're going through a project, and as we're making our way and getting stuff done in these increments, the uncertainty goes down. So at the very beginning of a project, I have all these forecasts. When I'm halfway through the project, the uncertainty cone has gone down. So I need to give that information back to the stakeholders. So in other words, I'm halfway through, I really should be 2/3 the way through. I'll work it out on my Gantt chart, and I'll talk to the stakeholders. We are going to be a month delayed. You thought you were getting this in June, you're getting it in July. And here's the why of it, all right? So that we can actually deliver a proper solution. So are we done? Right? This is what this talk is all about. So that's just terminology. Now we're going to actually talk about stuff, right? So forewarning, there is a school of thought, right? And I think it lives more in the management layer. I hope no one's a manager here. It's never commit to anything concrete, be slippery, be vague. You can't be held to account, right? It makes it very difficult to work with, all right? Right? And it's not that being vague or being imprecise gets you something done well. It's not like it's doing anything other than saying, I believe this thing will fail, and this is me covering my ass while I do it. All right, so if you're here, this is not this talk. You need to go to a different talk for this. This is not about, this is about delivering better outcomes in your software. All right, so let's begin. So anyone here, anyone I've talked to has heard of Maslow's pyramid of human needs, all right, which says that civilization has to start with layers before we move up. So the very bottom layer is food and shelter and warmth and stuff. And then you get into the next layer. And until that's done, you don't get into communities where you have little, wooden fences around. You've better security, you've got help. And then you go all the way up in various stages. So you get to the very top where you're writing Shakespearean sonnets, self-actualization, being all you can potentially be. Yes. Nice. Okay, so I said, you know what? There is an analog to that in software engineering. We also have a certain amount of layers that we have to build upon, and if you're missing the one above it, you have to go and do the one below it first. So let's talk about development. Is development done? Right? Have the changes you have agreed to, because we now have scope changes and everything else, have been verified and applied? What do I mean? Have they met the acceptance criteria? Right, either fully or partially. Sometimes if you slip, you say, well, I can't deliver it fully, but the partial piece I've done right now is value and will make the customers happy. Let's ship that while we're waiting on the rest. Has it passed all the tests driven by the validation system? Right, because we have I don't, I'm going to say we have a vague idea of what the dependencies are when we make a change, but we certainly don't, on a complex system, know them all. So we should have all these unit tests and integration tests checking all parts of our system, not just the piece we've changed, to make sure the system still runs as well as it did before the change. And then the piece that's missing is adding tests for a new change. Who here writes changes and doesn't put unit or integration tests with them? Okay, only one guy. All right. I wrote software to pull that data out of the software repository Git repos. It's way bigger than that, right? It's over 50% putting stuff in with no tests on it. And the other thing is the acceptance criteria and the testing and stuff, that just means you're getting the correct answer, right? You're doing the feature properly. It does not mean you're doing it any kind of sane way, right? You could do something completely bizarre under the covers, completely inefficient, brittle. That's what your code review is there for. And that's why you need engineers that are able to do proper analysis of your code so that they can stop this stuff getting in production when you're doing stuff that's really very weird and very inefficient. Right, is it merged into a package for production release? Some people say, yeah, you know what? It's done, here it is working in my clone. Yeah, well, is it in a package for production release? Because it's not going anywhere till it's merged and put into the package. So it's ready for deployment, all right? So at this stage, people say we're code complete. I maintain that's a bit of a fiction because if there's a problem or a bug in there, it's coming back to you when you're doing more coding, right? So it's your kind of V0.1 of code, all right? Who uses this as a measure of doneness when they're giving some feature or bug to fix? Not bad, not bad. It's not great, it's a really bad definition, but I'm glad you have some definition. All right, you need something to shared understanding again. What about deployment? All right, it's sitting in your repo, big whoop. All right, no one sees it, no one knows it's there, no one even knows if it works properly. Right, so are the changes deployed everywhere? And I mean everywhere, not on one machine in production that if you turn the right knobs, you can get to it. Right. What is the pace of deployment through production stages? We have 6 stages. Right? So it takes 6 weeks to go out, right? And until it hits that last stage in production, to me, it's not fully deployed, right? And why do we use stages in production anyway? Why don't we just say hit every stage in production with the change? Well, I'll tell you, right? Usually our most important clients are on the very last stage, and I won't say our least important, but our less business contribution of value people are in the early ones, and they get to hit the software first. So we see the changes if they're a problem, right? So what's the pace of deployment, right? And when is it deployed? Like I say, everywhere. And I'm always saying that to people. When's your change done? And by that, I mean deployed everywhere in production, right? And what is the staggered dependencies? If I've got another group that's feeding into, like there's 2 groups, I got to track both groups and see how they're doing as far as interleaving with each other. And something that plagues me is code freezes. It's a general election, we're a holiday. Anything where everyone's out enjoying themselves, we can't be pushing production changes in, right? We want to keep the code stable. Who uses this as a definition of done? If no hand goes up from here forward, I'm worried. I don't know, I think you're just trying to make me feel better. Some people are just putting I think it's a pity hand up. All right, so feature flags. Do people know what a feature flag is? Anyone here know what a feature flag is? Wow, but half don't. Even you, John. All right, so what is a feature flag? Right, it's just a software development tool to allow us to enable or disable changes at runtime. So I don't have to do a rollback of the software if there's a problem with the new change. All right. Why would I do something like that? Like I said, these are just if statements in the code. If the flag is on, do this thing in the new way, else do it in the old way. And if the new way is causing problems, flick the switch, software doesn't really even have to be rebooted, and now we're doing it the old way, I'm good. And the reason we do that is we can disable a single change or 1 or 2 changes and not affect changes that are actually working. When I check code in, there might be 10 other changes, some of them critical fixes. And I don't want to say, well, my little change made me roll the whole code base back. All right, so feature flags. Oh, and by the way, when I say untested code, I don't mean we've never tested a code. I just mean it's never run in production. Yes.
Good idea.
Okay, John says, yeah, we have a strange name for Bloomberg. Yeah, in Bloomberg we call it a B-reg. I think other places, I think feature flag is more descriptive. Yeah.
Feature test it. Stand.
Like, that's like,
Very good question. So Jason says, what does the feature flag do to your test suite? So I know what it does in our test suite is you do a parameterized Google mock with that flag on and that flag off, right? And then when you get rid of that particular thing because you say the new way is working, you can just delete the whole other branch. All right. So deployed code that's not utilized in production. Now, feature flags stop this, right? People deploy the code and then turn the switch on a little later, right? So again, I've been bitten by this. Why is your fix not working? You said it's in the production. Oh yeah, we haven't flipped the switch on this yet, right? So you got to track this as well. Similar to deployment, right? Is it enabled everywhere? The pace of it? When is the enablement complete? And when you say when is the enablement complete, what are you looking for? Huh? Yeah, but when is it complete is everywhere. But what am I looking for? When? What's the when got to be?
when it's remote,
A date, yes, a date. We talked about it. A couple of weeks from now, whenever we'll get to it. No, give me a date, right? So I can go in and say, this is where it's actually enabled in production. And then the other thing is, when is that feature flag being removed? Because it puts dead branches in your code, but we'll deal with that sometime later. All right. So this is our software engineering pyramid. I'm going to fill in the bottom layer of this pyramid. Right? You have to do all these things. And if you can do these things, or a company can do these things, congratulations, you can get a code change all the way from your requirements into production, right? You have achieved what I call code survival, the very basic layer, right? And congratulations, you are now a competent coder. If this is what you do in your day-to-day, you're a coder, right? Cool, all right? But I'm going to say that's not enough. Same way, like I don't want to eat raw rabbit in a cave. I want to be in a house and stuff. There's another layer in the software pyramid, all right? So I have a rationale for that, right? Why is that survival not enough? Well, any system where engineering is just invested in feature development and bug fixing, that code base will over time devolve into something that's complex, brittle, we call it legacy, hard to work with. All right. We must strike a balance between rapid feature development and a sustainable code base, right? And efforts are needed to stabilize the entropy that's going to come in with your code, right? As stuff is added on year after year, entropy builds up in your code base. All right. So let's talk about code health basics. What is software decommissioning? That's a question. Anyone? John is answering all my questions. Yeah, it's a strategic process of retiring outdated software, right? And any related infrastructure that it sits upon, right? And that gives us better maintainability and efficiency. You should only have code that's actually used in your code base. You shouldn't have lumps of it, big pieces of it lying around that never get called, because no one does that anymore, all right? And there's two categories of this, all right? At least the way I see it. There's code that is structurally you can't call it. It's never able to be accessed. Someone put some new way in of doing it, pushed the code to go down this particular path, and just left this thing sitting here. And it sits in the code base year after year, and people will come in, oh, let's refactor this code base or something. It's like, no, it should have been taken out. It's noise in your code, all right? The other type is a lot more trickier. It's we don't believe this code will ever be accessed anymore because of user input. We used to do, in Bloomberg, we used to do these kind of trades. They've been replaced with doing this. We have a tick type coming from one of the exchanges. They've updated with a new type. This is now obsolete. All right, that's a little trickier. You have to kind of monitor the usage over time and say, I think it's never showing up again. So it's a little more of a, and right, whatever length of time makes you comfortable. And then feature flag removal. Like I say, if you say, here's a new way of doing things, I flip the flag and I leave it there forever, right? I've got a dead branch in my code that just makes things longer to compile, harder to figure out, because when you're down in all the functionality of the other one being called, you don't know that there's a feature flag up on top. I had that happen to me. I was refactoring this big piece of code and someone said, there's a bit switch or a breg or a feature flag right up there that this is not actually used. I think it was 2016 or 2018 it was turned off, all right? So not a good position. So decommissioning, is it done? All right, was there any decommissioning needed? If you're doing something new to replace something that's there, have you planned to remove the older functionality? And by that I mean, here's the JIRA, and there's another JIRA item in some timed alarm area, which goes off 3 months later saying, it's time to do this in the sprint. And it should be pretty quick, straightforward. It becomes less straightforward if this is something that's left there for years and someone comes along and doesn't quite know what this code is doing and has to kind of reverse engineer it. All right, is there any feature flag removal? Right, needs to be done. Have we eliminated the dead branching in the code? So that's one aspect of code health, right? This is not to do with delivering features. This is to do with keeping your code base maintainable so people can add features in better, easier, less friction. More code health basics. What is software refactoring? All right, it's a disciplined process of changing a system software. We do it to make things, improve the internal structure, to make it run cleaner, more, what I'm going to say, more easy to scrutinize how it's running. Sometimes you get efficiency. I think that's a byproduct. Lots of times efficiency can really, if you're going after it, like if you're in a high frequency trading, you're kind of sacrifice that because, speed is everything. But other than that, you want to improve the internal structure. So why is refactoring needed? Right? Why are we not just putting in, eternal solutions? Yeah, code ages and gets more, someone says gets more complicated, right? We add new business lines in and they're like variations of the old one, but someone's copied the code instead of making it just a one function, right? It's 99% the same, just one thing different. All right, but it's usually to do with tactical versus strategic implementation of a change, meaning I've got to get something in quick for some reason. I don't have time to do the proper, the full-on, let's say, proper solution. And this comes from time challenges, I'm going to say, is something that is imposed kind of from without, or you didn't properly estimate what was going on. You didn't see that would be refactoring going on, so you didn't have a time budget for it, or you didn't have adequate time to research what you were doing. So these are all things that you kind of should have taken the time to analyze the problem up front, but you didn't, right? And the other thing is, when you don't have time challenges, this stuff gets into your code base because you have poor code reviews. You have no standards, you have no floor of what you should be expecting for code solutions. You're just like, yeah, my friend and me, we just approve each other's code. Right, that's the usual way a lot of bad stuff gets in, because I shake your hand, you shake mine, and we draw a check. Right, and I will tell you, in my experience, which is 30-something, whatever years, if you don't refactor your code over time, it's heading for a rewrite. That cruft, that dead code, that serpentine way of doing things, that duplication will all over time make it a rewrite where you have to go in and say, I can't make now usually someone moves out, someone new moves in, taking over the group. I can't work with this code, we need a rewrite. And management goes, we hate rewrites. And the reason they hate them is they usually fail because we don't have proper requirements, we don't have proper scope, we don't have all the stuff I talked about earlier. So is your refactoring done? Why would I need refactoring? Right, I've got recurring duplicated patterns in the code. We used to do one thing, now we're doing many things, and we're doing them all just slightly differently. We should be refactoring that functionality. We got low readability or maintainable code. We look at the code, no one can figure out what it's doing. Got lots of code smells, raw pointers being passed in and out, overly complicated logic, I seen one where it was a for loop, which was going up 16,000 iterations. It was kind of if it's less than some max number, which is 16,000, just keep going. And then when we get past 16,000, actually do something, right? That's a terrible solution, right? Especially with views and ranges. You can just say, make this into a view, drop it up to this index, and now just do a range for over that, right? That's, again, knowing, we'll talk about that, knowing what's in the language. Paradigm changes. We're doing business in a completely different way. All right, so we used to do it one way. There's been some big shift, or we're doing some big move, so things change. We have a thing called technical depreciation. It's not tech debt, technical depreciation, because the code ages. No matter how well code is written, it starts to show its age, right? Due to advancements in the language, advancements in engineering, new third-party packages coming along. All right, I mean, I see code written from 15, 20 years ago where they have kind of an optional. You can't say to them, what are these clowns doing? We have an optional since C++ 17. Yeah, this was written in 2002, right? So stuff like this is just going to make your code age. You got to go in and bring it up to date. So what is tech debt? And this is a question for you guys, because we talk about it a lot. John. Okay, so anyone who's in YouTube land, John's saying it's like a mortgage broker, right? So getting debt and stuff like this. Yeah, I mean, I'm saying what technical debt is the cost of reworking, fixing code in the future due to some limited solution you applied, some quick hack you applied now. And it's not just that in the future you have to undo the hack and do that, do it correctly, right? Every other solution in your code has to work around with that hack, right? Making possibly more reworking need to be done in the future, because everything that's working around the hack also has to be engineered. And that's why you want to set the payment terms up front, right? I'm more simple. I don't like big, long definitions. I just say it's unnecessary complexity in code. If you bring me something that's got a whole bunch of complexity in it, templates, I don't know, all this kind of stuff in it, I go, this is just a regular class with a couple of functions on it. It's like, why are we doing this? This is, you're injecting tech debt into my code base. So these are the things that make tech debt happen, right? Where we have deadlines that are imposed from without, so we have to do things quickly, or firefighting something in production. So these are maybe stuff from without that's making us put tech debt in the code, right? The other things where we have cleverness, premature optimization of code, a lack of a good culture, lack of standards, poor code reviews, they're things we do to ourselves, right? We can't blame anyone else for that. That's stuff we do to ourselves. And then the other one is more time, right? Organic growth. In other words, no one could see where the software was going, so it's become a little disorganized as we, put one independent solution of another instead of having a strategic direction of where we should be going, right? And poor documentation. And this all happens over a span of time. You don't wake up on Monday morning, well, you shouldn't. Like I left here Friday, things look great. Monday, there's a ton of technical debt in the code, right? It gets put in small increments. Right? It's insidious, worms its way into your code base. That's why you have to have people who are looking out for this, right? Who are aware of the code health. They're not just into the rapid feature development. Let's talk about tech debt. There's a guy, Napton, and he had this quote, and I thought it was gold. There is nothing so permanent, and I say, in software engineering, as a temporary decision. Let's, for now, do this. Well, okay, we'll do that for now. But when are we going to revisit that decision? I don't know, sometime in the future, right? You're not coming back to it. I know you're not. And there's categories of technical debt. Who here thinks all technical debt is bad?
In the long term.
Who here thinks all technical debt is good? All right. Okay. Look, there is two categories of tech debt. There's intentional. Just one second. There's intentional tech debt, and that's where I'm trading quality for speed. I have a strategic reason for getting to market quickly. I'm willing to go with a less full-on solution, so I get to market on time. I'm having regulation dumped on me. I can get it in on time, right? But it's paired with an item on the backlog to mitigate and go back and fix what was done in a hurry, right? And you set those terms now, and you set them the next item on my sprint is going to be this. All right, not, well, you know, we'll do it in a couple of months' time, because you know it's never getting done. The other type of debt, this is, I'm going to say, good technical debt. It's taken on consciously, and you have a plan to get rid of it. The other one is what I call unintentional tech debt, right? There's no strategy. We're not gaining anything by this. It's not like we have deadlines or stuff we're pushing through it. It's just doing a sloppy job, right? It's just having someone review your code and go, yeah, it's fine. Tons of debt, raw pointers, right? All this thing going through. And there's no plan to mitigate it. And that means your code base over time, again, starts deteriorating. And the same guy said, in my team, a project isn't done unless you go back and adjust whatever shortcuts you took as technical debt. And everybody agrees, I assume it's in his team, that this is how we define done. So they don't say the quick win, you just got this thing working, it doesn't matter how it worked, that's fine. It's like, it's working and we didn't introduce tech debt into the code. Who uses this as a way of getting things done? Two people raising their hand. Okay, this is a great definition. I think this is something you should be teaching in schools. Done means not just that you made it work, it's made you made it work and you've fixed any problems or shortcuts you took because of external pressures on you. All right, so how do we track tech debt? Right, because, you know, you say kind of in there, but it's okay. Right, you make a list, a pretty simple list. What's the size of this tech debt to fix? Small, medium, large. What's the severity? High, medium, low. Just a ballpark figure and how it's impacting you. You got to be intentional. You got to add to the list when suboptimal solutions are used. I tell the story of where it was the end of a quarter and I was talking to a team because I seen a code review and I said, this is done in a very odd way. It should be done this way. And they were like, well, yes. And 3 people, me and 2 others, agreed this was the strangest way of doing something. And it was like, but we've all agreed as a group, we'll put it in because it's the end of quarter. And I swear in the next quarter, we're going to fix it. Right? That was like 9 months ago. It's not fixed. I keep an eye on it. Right? It's not fixed. So add it to a list. And why did I want to get on the list? Because I thought they're saying we're doing suboptimal work. We're putting in bad solutions, and no one wanted to admit to, you are putting it in, but you're putting it in for a reason, and here's you undoing the badness of it. All right. The other thing, you got to keep it visible. I used to, when I was on teams, advocate for tech debt sprints once a quarter. You got 6 sprints in a quarter, make one of them tech debt. Fixing, refactoring, all the stuff to make the code base healthy, because it will creep in if you don't do it. And lots of people say to me, yeah, but management, leadership, they won't let us do this. And you're right if you just go, look, I want to take 6 months to do some refactoring. I want to take my team offline almost and do it. They go, you're not doing that. We got stuff to be doing. But if you can highlight what risks are happening, this is the reason you're having rollbacks in the software. This is the reason you're having outages. This is why your time to market for simple fixes is this long. Right? The fix of bug fixes is really torturous and it takes us this long to do it. You parade them in front of management, they then come around to your way of thinking because you can show them the cost and have it backed by data, not just like, I think it's doing something. You know, analyze the data that's there and show them bar charts and pie charts and say, here's what's happening. And this is the why of it. I know you have maintenance load. In other words, the stuff we're doing that's not to do with putting features or keeping the code base healthy, it's the kind of treading water. How am I doing for time? 35 minutes. Ah, cool. You have a question? No, I'm an hour and a half, John. Yeah. I was going to say something smart, but I won't. I'm on camera. All right, so is your tech debt done? All right. Have you got tech debt prevention measures in place? Like I say, you properly plan out your timeline. We talk about breaking it to steps. Having design reviews, so people don't say, this is what we're doing. They run off and come back 2 weeks later and say, here it is, a fully implemented solution. You go, oh, that is probably the worst solution I've ever seen. Let's backtrack down about a week and a half's worth of work, right? So what's the design options we have? Get more groupthink into it. Code review guidelines, right? This is something I'm doing in my own place because I find that the code quality of what's going in is hugely variable. So give it just a 2 or 3 page document on code review guidelines. Here's the things to look out for. And actually works well with AI now. You can just feed these guidelines into the AI and say, review that code for me. All right, and then come back and say, look, here's the stuff even the AI can spot. So you should be able to do it as well. Why am I seeing it? All right, now you're smacking of laziness, not lack of knowledge. Coding standards, a little more tricky. These are usually big tomes. You say, well, we have coding standards, yes, but who sits down and reads, 5,000 pages of coding standards? You just pop into one piece or other when you have a little confusion. And like I said, tracking it. You track it and champion the demise of it, right? And last is training. Do we train people to do code reviews? Do we train people on design reviews? No, we just say, look, you've been around long enough, you're automatically a code review champion, right? Why? Because you've sat on that seat for 5 years, that's why. And you really know the code base very well and you can find out problems, normally because you're the one who put them in, right? I know where all the bodies are and no one else can figure it out, right? That's, again, tech that in your code base. So let's talk about testing. All right, so testing. We're doing a lot better these days on testing. We're not doing that well. So we have the 3 testing pillars, right? Unit testing, meaning I'm testing just one little piece of the code. I can write happy and happy path testing. It's really simple to work with if I've got good dependency injection. Close to the developer, I get my feedback in 20 seconds when I do a compile and test. Integration testing, a little more tricky. I bring my whole task up. I've got fake dependency tasks around it, feeding it defined data, so I can see if it's working all as one piece correctly. If there's a problem in there, it's a little harder to find because I got to figure where or what change in this vast code base caused this bad behavior. And last is end-to-end testing, right? It's actually you're putting it into stage 1 or something in production, and you're running fake data through it, or synthetic data. So if you're doing trades, it's with synthetic brokers and buyers. It's a synthetic exchange in our case, where we're sending in ticks from an exchange. All right. So these things have to be done. Some people say, well, look, end-to-end testing is all you need. And it kind of is. I mean, that's where you're seeing that everything works. However, it's like having, I don't know if you ever see the Aliens movie, where they're like, the aliens are 30 foot away. They're 20 feet away. They're 10 feet away. It's like, they should be through the door. Where are they? Right? They're actually upstairs, right? So in other words, end-to-end says there's something wrong. It's really usually very hard to figure out what's the cause of that. You want to try and push your problem solving down into unit, where it can be done if possible. Some stuff can't be done there. Integration, if you can do it there. And end-to-end should be like the last thing you're really relying on. And why do we do all this testing stuff anyway, right? When you can just say, look, I know I'm right. Launch it into production, let the chips fall where they may. Because that's how you maintain quality in your code base, through testing. Make sure the customer sees what we expect them to see. So, is your testing done? Are we leveraging the experience of what we're finding out with production outages, problems in production, errors that have happened? Are we creating tests based on production problems we are seeing? In other words, I find coverage is a tricky thing. I think it's more or less forgivable. I didn't see this confluence of events, and it took our system down. And you say, here's the fix, and you put it in, and then it goes down 2 months later for the same reason. And you go, well, yeah, I did some one-off test on a machine. It's not something that happens every day of the week, and someone inadvertently undid undid or put new conditions in that broke it. So are we creating new tests based on production? Because if the same problem shows up in the same way in production a second time, I want to know why, right? And I want to go to not the guy who did the fix. I want to go to the guys who reviewed the fix and find out why they let it through. Do we have out-of-it test coverage? Are we identifying corner cases, right? The things that give us trouble, not just the happy path. Are we testing unhappy path? What happens when we get screwy input? Making sure it doesn't take us down. We don't go beyond the end of arrays and stuff like this, right? And then the other thing is we want automation of these testing. So yeah, with the unit and integration tests, you can kind of say it's part of the CI, but the end-to-end testing should be kind of going on as health testing in production anyway, right? So that alarms go off when something is going. You can see something going through the stage in production and the red light going on each time it goes to a new stage. something's wrong there, stop the deployment. So my original rationale was, why is survival not enough? Why are we not squatting in caves doing computer programming, right? It's because we have to invest in something other than just features and bug fixes, right? And that's that reversing the entropy by doing stuff with code health. So now I'm going to say the second layer of this pyramid is this. To do with code health, keeping your code sustainable. In other words, it doesn't just work today, it's going to work in the future, and we're going to be able, it's flexible enough to absorb change. All right, so if you've done this layer, or you're concerned with this layer of what goes on in your code base, great, we have a sustainable code base. It means it's not going to just fall over one day that no one can manage it. Congratulations, you're now an engineer. All right, you're not a coder anymore. If you think of these things, give yourself a pat in the back, you're an engineer. All right. Now, your sphere of awareness is going to get bigger as you kind of absorb more concepts, right? So what's the next layer of this pyramid? And what I found when I looked at it, there's kind of a really different change of emphasis when we hit the next layer of software engineering, the next level of awareness, right? So there's a change of emphasis. We go from are we done to are we prepared? Are we prepared for something that's coming? And that, again, they mean, are you prepared, right? Is your team prepared? And the answer is, again, probably not, because we don't have proper definitions of what we're talking about, all right? We're trying to do engineering on the fly as opposed to do it in a structured way. Okay, so let's talk about the next level. It's going to start concerning things like system reliability and resiliency. Everyone talks about reliability. I think resiliency is starting to get some traction. Like, what is system reliability? Shout it out. Come on, you guys over here on the left. What's reliability of a system? You guys are not on the business side, right? You guys actually, right? You're engineers, coders. Yeah. The system keeps running was the answer, yeah. It actually performs its intended function with no failures or downtime. That is perfect reliability, right? However, we don't get to perfect reliability, and that's where resiliency comes in. Resiliency just means that your system will degrade gracefully. It won't hit some cliff, core, go out of service, stop doing what it's supposed to be doing. You get a degradation in service or functionality, but you're still doing some of the job, right? People can still work. So why do we care about resiliency or reliability? I mean, what has, so, you know, the service went down for an hour. Why do we care? Yes. Right, so you said trust. It's like it almost, and by the way, I did not prime the audience here, right? User trust, exactly, right? People trust what you're putting out there. What you're talking about, John, is business continuity. People that rely on your software don't have the business stop for when you have unreliable software. And if you're in big enough companies, you know, Google or Bloomberg, I mean, if Bloomberg stopped sending out, I'm going to say ticks on the monitor for, I don't know, 10 minutes, we just stopped putting out ticks for 10 minutes. You know that's on the 9 o'clock news that night. Bloomberg, tragedy, blah, 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 right? So this is why we care about having resiliency and reliability. So how do we get there? How healthy is your system? Well, how healthy is it? Right? Are changes impacting your system's aggregate health? So in other words, look, there's all changes coming in from different teams. How is the overall system doing? Is it up all the time? A very, very occasional outage, and it's due to some really strange confluence events. Do we have a couple of guys hired just to bring the system up every time it falls over because it does it a lot, right? What is the impact of all these changes going into your system? Can you catch these problems before your clients notice? I mean, how can you do this? How could you gaze into the future and see what your clients are going to have problems with? Huh? Testing will do it, yeah, but it's not going to be enough. All right? You have to have system health monitoring. You have to have observability into your system, what we call operational metrics. You can see how your code is performing up to when it fails, right? So we have the LETs, which is latency, how much time it's taken to service something, throughput, right? As the load goes up, how is your throughput affected? Saturation, what's your queues, your memory, your CPU? Are they saturating out? And over time, you might see this thing starting to go up. So you can see problems before they show up, right? What's the rate of fails in the system? And I don't mean failure like, I said to the user, I use the ATM analogy, he wants $50 and there's only 20 in his account, and I say error. That's not an error. That's doing exactly a desired outcome. An error would be giving him the $50, right? So this is the kind of thing you want to do to be able to get to observe your system, how it's working in production, and be able to predict what's going on. So when we use system health monitoring, what do we get out of it? Well, we should have automatic alarms, right? We don't need eyes on glass. I was telling you about the hot loop in the code, all right? It shouldn't need a random developer spotting this and going back to the metrics and say, wow, look, if you go onto the screen and look, you can see this big spike since this went in. There should have been some alert, some automated alarm set off that people come and look at it, right? So it avoids imminent outages. But if you monitor trends over a span of time, right, over 6 months, 12 months, we can see the load getting up. We can see where maybe our circular buffers are going to start saturating, where we're getting too much latency as far as getting stuff through our system. We can see that over time and plan for it. Right? We do capacity planning. I don't think it's production support. All right. So any new technology or features, I mean new to you or the company, are being introduced. Is it supported by current ops? Right? You're the first team that grabs some rust and puts it into production. And your ops team know nothing about it, know nothing how to do anything with it. Is it supported? No. You got to think about that, right? How are you going to support it? If you use your developers to support it, it's really hard on them. They tend to leave your team, all right, because they don't want to be called at odd hours in the morning. Have we got distributed triage? What I mean is when there's problems, is it widely known or most people in an area can figure it out? I've had been in groups where some guy has wrote infrastructure, no one else can follow it, and we have a problem with it. And I kid you not, the guy was on a beach in Mexico for a week. All right, and I wasn't part of that team at the time, but I was looking at what was going on with some wry amusement. And they spent 2 days and said, we can't figure out what's going on. You have to wait for him to come back, right? So don't be waiting on the guy on the beach to come back, right? You should have it spread across your team. You should have proper logging and observability we talked about, and you should be doing runbooks, right? As you have problems show up, here's a description of the problem, here's what you should look for, and here's how to fix it or who to send it to. So the people who are doing this thing can get on the problem and narrow it down straight away. Improvement planning, right? Identifying areas of risk. There's parts of the system that just don't work right. We have to go after them, right? It's usually a more broad-scale functional change. It means we have multiple stages, iterations. It's a complicated problem, multiple teams involved. And we got to think about the risk to production because this is probably a sensitive part, which is why people haven't updated it because they're afraid to. Probably not a lot of testing associated with it. So there's a lot of thought has to go into risk. And what are we going to do with predicted timelines? What are the timelines for something like this? It usually should be about a year or less, mid-level. If it's something that's just like a month, it's not really improvement planning you're doing. It's just some local re-engineering, all right? And it's non-trivial releases. So you expect to have fixes to your change to come in. And there's many external dependencies. And like I say, I was running a project with 25 teams and keeping them all in lockstep, coordination and making sure the communication is happening takes a lot of time. All right. It's frustrating, but it's worth it because you actually get to deliver a product. Architectural design. All right. What I call local re-engineering. I'm changing the comms out. I'm going to change how we track state in the machine. I'm going to change something pretty broad that's right across our whole system, right? This is something I think that we normally associate with staff engineer, right? The broad architectural changes, right? Individuals are working on pieces. This guy is looking at the whole system. What is the vision? Lots of times it's because this thing's gotten so old, it doesn't have the capability, doesn't have the performance. But changing it is a probable nightmare if it's not done correct. All right, you get half changes where some of the system is going through this now, and then it stops, and now you got a system with two ways of doing things and no way of pushing forward with the other one, right? So you've got to have proper vision for managing this kind of stuff, right? And we look at where we target the system for most benefit, right? Engineers tend to go, we need to wipe the whole thing out, rewrite the system from scratch. That's the way it's done, right? It's really a bad solution, right? If you've been in a few rewrites, especially the ones that don't go so well, you'll know why, right? You have a really simple idea of how reality works. And there's stuff in the code which says, do this one way, and for a completely arbitrary reason that a business guy gave you, or an exchange, if you do it another way. If that doesn't feed into my clean set of classes, yeah. All right, and I did a redesign talk which goes into that in depth. And also when you're redoing stuff, don't be thinking again of redoing everything, right? Can I use the same database? Can I use the same, change one thing. Go after one thing and go after it well, as opposed to going after, I need every new technology in the place. I'm going to use, I don't know, some non-SQL database, right, Cassandra. Okay, fine. And I'm going to use Kafka now instead of some MQ. And I'm going to do something else. And I'm going from O3 to C++20, right? That's just going to be a mess. Try and see where you need to target your system for most benefit. And now we're starting to move, like I said, up this pyramid. We're going to start looking at bigger issues. What is the strategic vision? Instead of just lurching from one improvement to the next, right? How can we have a strategic vision of where we want to go, right? They're long-term, and they are really beyond the technical details, right? So it's a layer above architectural planning. It's where that business is going to go and how we're going to get there, what we've seen in our predictions, what we need to take care of, right? We're going to be dealing with shifts in how business is done, technology shifts. We're going to move to the cloud. We're pulling in AI, stuff like this, large-scale changes. How are we going to do that in a coordinated way across our whole organization? Essentially, we're going to do some future-proofing. And with these kind of decisions, usually weighing a lot of trade-offs. There's no one right answer, no one right way to do it. You're saying, if we do it this way, here's the pros, here's the cons. The other way, here's the pros, there's the cons. And we have to get some consensus between both business, stakeholders, and engineering. So how do you know you're in a strategic planning session? I say, it's on the actual name of the meeting. It may be. It may be. Maybe say this is a really strategic meeting. But you have many people involved, right? Usually higher powered people. That's how you know you're in something that's strategic. Usually the more people that are involved and the more powerful the people involved, the more strategic this is. The time spans are multi-year, even 5 years, going out to a decade. All right, so we've long time horizon. The longer, it's probably the more strategic. And we have longer term outcomes. And because it's a longer term outcome, it's usually difficult to change. Which one of those?
50.
Okay. It's longer term outcomes, right? It's not easy to change. We've just decided to move everything to the cloud. 2.5 years in, we're like, this is really a hassle. We're not getting the benefits. It's very hard to walk that decision back, which is why these things take a lot more analysis and a lot more people getting in it. So again, I had the rationale. Why is just having a sustainable code base with features in it not enough, right? Well, you have to go to the next level, right? Because that's just maintaining the current code and being able to put changes in. But the code lives on machines, lives in hardware, compilers, right? The business, all that stuff we're talking about, right? So we need efforts to plan for the future. We have to plan for the manual toil being reduced. Right, if you just let that will get away from you. Most of your engineers are just trying to keep the fires from banking up. Capacity planning, observability, all of this stuff is what you're concerned now with the aggregate health of everything, not just your code. Again, that awareness is going up. Right, so further efforts are required when we're going into the long term. So now I'm going to fill in the penultimate layer of this pyramid. Right? This is when you're looking more forward. You're trying to think not where the code base is, where we're going, and how we're going to attack the challenges in the future. So now you have a reliable system. This is the next layer. You now have system, you've got good system reliability, changes going into your system. All these changes don't break your system very often. So congratulations, if you're doing this kind of effort, you're a competent system engineer now. All right, you've just gone from being an engineer to a systems engineer. Yeah, and you're competent. That's the other thing. You're not just a systems engineer, you're competent, right? More rationale, I don't think that's enough. All right, I'm not doing my Shakespearean sonnets in software engineering yet. Right? Why is this not enough? I have a reliable system. I can get code changes in relatively quickly. I'm flexible. What else is there to worry about? That's a question. What would you worry about? Huh? Yeah, I mean, that's like world peace and no hunger. That's, you know, working the world around, in real terms. Visibility, I think if you get a certain amount of that. I think that was the last level. We're relevant. John?
Marketing and adoption.
John says marketing and adoption. Okay, look. Engineering must align with the business. If engineers pumping out a whole bunch of stuff the business doesn't need or want, or missing what the business is actually asking for, then we have an issue, right? We have to communicate. You know, I mean, business is a dirty word to a lot of engineers. These guys don't understand the beauty of my latest range view. It's a thing of wonder, right? It's like they just want to see, look, I need to do trades of this type. There's a new type of split trade going on. There's new type of regulation coming in, right? So engineering has to understand and align with the business, right? They're essentially who's writing our checks, right? So it's a good thing to please them. But also business must understand the constraints that engineering is operating under. They can't just be whistling Dixie, I want this, I want that, I want the other, and not realize that engineering has finite capacity. Some changes, what is the ROI in these changes? What are we getting? All right, various ways of doing it. So the engineering has to have business understand this, and this is why it's a two-way street of information. So to do that, we have things called roadmap meetings. Right? What is a roadmap meeting? Right? It's not just a general meeting by the water cooler or, hey, few people are going to come along, we're going to just shoot the breeze on this stuff, right? What is the roadmap meeting? Right? It's a formal meeting. Has to be formal, right? Meaning stuff is wrote down, right? So now everyone's going, yeah, I think a year ago we agreed to this, but I'm not quite sure, right? It's a formal meeting where we discuss current progress and future direction of some large part of a project, some like company-wide project, some company-wide initiative. Bloomberg for me was Linux migration was one of these big initiatives we had to take a crack at, right? And we want to make sure everyone is striving collaboratively in the one direction. We all share the objectives. We're not, I have one idea, here's another, and they're both incompatible, right? So we need to get involvement of stakeholders. So a roadmap meeting has to have a certain composition of people that's in there. All right. We need the product owner. In that case, for migration, it was me. So that's where like chips would fall if it didn't happen correctly. You create the roadmap, right? And what are strategic goals? What are we trying to get done? And why are we trying to do it? We also want the business analyst or proxy to represent the user so that to make sure we are doing proper engagement. In other words, the user is not under the impression we're doing one thing, we're under the impression we should be doing something else, right? So the user engagement business goals are brought into this meeting. You have development representatives from each major area. For me, it's the heads of each of the sections, right? Whoever runs the manager of the database section, the market distribution section, right? The business logic section. Right, they're all there, and they're there to say, like, look, here's problems we're going to have with doing this, or here's risky stuff. We have experience with this in the past, and it hasn't gone well, right? And you need an executive stakeholder, department head, someone who can make a decision, everyone else accepts it, and it sticks, right? He'll listen to people and say, I'm coming down on this. Right, so you need approval for your decision making. And then we need a product manager or delivery specialist, or sometimes called agilist, but I think that's a limited form. These are the guys, when I feed them all this data of the times and what needs to be done, they produce Gantt charts for me. And they say, in July 2027 is where this thing lands. Right, and when I go 6 months from now, here's the new data that's been gathered. You've just moved out to September. we're telling people a year in advance, so it's not that big a surprise, right? They might not like it, but they certainly won't like it when I come along and say, you know, in whatever I was saying, June, yeah, you're not actually getting it till December. And we thought we're getting it tomorrow. No. Bad news early is not as bad news right up late. So what do these meetings address? How do they run? How do you run a roadmap meeting? And again, this is because the communication, the facilitating. You review the current landscape. Where are we right now? What's gone on since we had the last meeting? Is there any roadblocks? Right? And this is a great time to have a table or a chart saying, here's the current blockers. This is a blocker on the DB that has to make a change. This is a blocker on the distribution of that information. And you just go, Mr. Head of Database, can you tell us what's the story on that? Explain it, how long? And that means it gets done. Very visible, there's high-powered people there. They don't go, yeah, we're not too interested in doing it. They'll say, oh, we're looking at that right now. All right, so that's what you do there. You're setting strategic direction. What does that mean? It means where we're going, how we're getting there. We get the consensus buy-in, so no one feels like, and consensus doesn't mean absolutely everybody agrees. It means that everyone has acquiesced to the group decision. I'm really unhappy about it, but everyone else said we're going that way, so I accept it. And then prioritization and resource allocation. In other words, in what order are things getting done and who? Right? With dates attached, obviously. Right? And the action planning that goes with that. Right? So in other words, at the end of that meeting should be actions. Here's a summary of what went on, and here's the actions that are agreed with the clear success criteria, not just we're going to do X. Here's what has to happen, and here's the dates that are attached. Okay, and we look at the long-term timelines. We see in that big, long Gantt chart, where are we now as far as where we're delivering? Is it acceptable? Do we need to do some kind of flocking on something to get something done quicker? Because this is something we can't move around. Future planning. Again, we're up at the high levels now in the airy spaces. Are we prepared for software stability? And if we're adding all this stuff, are we going to keep our software stable? Security vulnerabilities. Right, Herb's thing this morning, are we doing that C+26 magic that makes things safer? What is it going to take to get there and get the easy stuff soon? What about scalability? Every system that's in a successful business has scalability issues. All right, I know for us, in the early part of this year, the volume of what went on, as far as volume of data went up by three times, 300%. Right, and our system handled it. Huge win for us, right? But it's like, that's only because we've done a bunch of capacity planning, not when stuff broke, when we've seen this ramp. And this actually wasn't a ramp, it was a kind of a Right, and then, so what are you ready for? Are you ready for new technical opportunities, right? New ways of doing things that are going to be more efficient. What about business opportunities? Regulations, we're getting regulations dumped on us, staying competitive. Some small startup doesn't have 30 years of legacy code dragging them, right? Can you keep up? Can you evolve quick enough? So again, my rationale, engineer has to align with business. We have to have that two-way communication, right? Because engineer and business need to collaborate, compromise, and effectively communicate. So the final piece of this pyramid is business needs and engineering goals being in alignment. Now, I asked the question, so you've been a coder, an engineer, a systems engineer. What are you now when you're doing business into engineer alignment? You achieve that. What? Shout it out. CTO? No, I don't think they actually do that, but they tell people to do it.
Architect?
Architect? No. Yeah, that's a fairly fungy term. Is it distinguished engineer? It means different things to different companies. All right, look, engineer and business alignment have been achieved. Congratulations, you're a visionary. You have brought software heaven down onto earth. You have a really maintainable code base. You're aligned with business. Business understands what you're trying to do. There's collaboration there. You're able to take large strides when you're going forward, not mincing steps, taking one step and two steps back. Okay, so here's the complete pyramid as I see it. All right, and again, how does this relate to what you do? All right, so let me recap. I'm going to say, what level are you operating on? And what level are you aspiring to operate on? Right, so I'm going to do these backwards because it's the pyramid. Are you primarily focused with feature implementation and bug fixes? Right, is that what you're doing? And okay, we need people to do that, and maybe you're content. But you might want to gaze up and see, well, maybe what sort of code health practices could I be bringing into what I'm doing? Or advising people on doing code reviews. All right. So you're one layer above that. You've got more awareness of code health. You're not just slapping in changes and hoping they work, right? You're making sure it's sustainable. You're not crapping out the code base by putting in substandard or really weird solutions. Are you looking at your system's aggregate health? Right? Because at the end of the day, that's what the customer sees, the aggregate health and how the features are implemented. And like I say, when you get to the higher levels and future direction, market competitiveness, where's the business going, right? So this thing here, I think, operates from bottom to top with, I'm going to say, roughly time and experience or maturity. So in the beginning, you're more feature orientated. You get up, you're more, how's my code base, and you move up, right? Now, the thing about this is, when I look at our interview process, it focuses only on the bottom, right? Give me a leak code solution to this, right? Doesn't in any way map to any of the higher solutions we have here, right? And there's going to be a talk, the closing keynote, on that piece of the puzzle. All right, so, and to recap, software engineering, when are you done? I hope I've given you an idea that doneness is variable and you need to be way more specific. Right, what are you going to be specific on? What is the scope? Right, milestones, deliverables, acceptance criteria, follow-on work that's going to need to be done. The time, right, I know what I'm doing. What's the time? Deliverable dates, milestone dates, breaking things down into a bunch of little things. Intentional tech debt that you take on, right? Remediation is done. Communicate clearly to the stakeholders. This is what we're doing. Is this what you want done? Right, regular meetings of progress, making the thing, as someone said, visibility, keeps you visible, keeps that interaction going. So again, when are you done? Well, you're done when your change is running smoothly and engaged everywhere in production. That's my minimum version of done. And I never said done anymore because people don't believe that's what it is. I say, when is everything going to be in production, working everywhere? Is it well supported by the team? Don't be the team that needs the guy in Mexico to come off the beach, right? Is your tech debt decreasing or not increasing? Have you got structured, maintainable code, right? That makes happy developers. And once you have happy developers, you retain your engineers. When you retain your engineers, leadership is very happy about that. It's a real hassle when people leave a group, especially if it's a lot of experience just walking out that door. And ultimately, your users and clients are happy. They're happy it's reliable, they're getting what you promise on time, properly featured. And when they're happy, the business is happy. When the business is happy, you get good reviews and lots of money, all right? So you're poised to meet future challenges. So that's quite a journey, right? That's quite a lot of stuff we've covered, right? But I've only one final word to say on this, right? This presentation is well and truly done. Thank you, everybody.